We've created tables of values that work and didn't work for each of those. And now I'm going to remind you how we solve this algebraically. So what we did back in grade 11 when we solved an equation like this algebraically is you first found out where it was equal. So if I was solving this equation, x squared plus 9 equals 25, well, I could move the 9 over and square root both sides. And I'd find out that it's equal at plus or minus 4. And the thing that you probably forgot for solving inequalities is after this, you made a number line and you put those values where it was equal on your number line. So I put negative 4 and 4 on my number line. That's the only numbers I'm going to label on my line. And since we're trying to find out where it's less than or equal, you might have remembered putting these as circles and filling them in because that's where it's equal. So those would be included. After this, you tested values because these numbers of 4 and negative 4 separate this number line into 3 sections. And so if we try a number less than negative 4, like negative 5, what would happen at negative 5? Well, negative 5 squared is 25, plus 9 would be, so negative 5 would have gone on this side of our numbers that work or don't work. Negative 5 doesn't work, so we would say this is false. Trying anything between negative 4 and 4, well, according to our chart, 1, 2, and 3 work. So everything between negative 4 and 4 is going to be true. And we tried some very large numbers after 4. We found out that this section is false. One of the things that's sometimes done in this kind of equation is you make one side equal to 0. So if I took my inequality that was originally there and I moved the 25 over to one side, I would get x squared minus 16 is less than or equal to 0. If you graph this on the right, what would that make? A parabola. And that parabola would look like this. Can you see that it would have x-intercepts at 4 and negative 4? And what we're really trying to find with this inequality is where is this parabola less than 0? So if I had drawn my axes on here, right, we're trying to find out where are the y values less than 0. Well, we can see from the graph that it's true between negative 4 and 4. So graphically, we can also see why that's the solution. So when we solve this, we would say that our solution in set notation, we would write it like this. X could be between negative 4 and 4. Or if you wrote it in interval notation, you would use square brackets because those values are included, and you would go from negative 4 to 4. For our second equation, x squared plus x minus 6 is greater than 0. Well, if you had temporarily made this equal to 0 and solved for it, was it minus 6? Yeah. You could factor this x plus 3, x minus 2, and find out that your solutions are at minus 3 and 2. Following along the same lines as last time, we can make our number line. We can label negative 3 and 2 on our number line. And this time, when you draw the circles at those values, you might remember that we didn't fill them in because the original equation didn't have an equal sign. And that's why on our chart, we had negative 3 and 2 listed on the x values, the ones that didn't work. Because it's equal to 0 at that point. It's not less than 0 or greater than 0. What was the, it was greater than? So now that we found out that those are our two sections, we need to check something less than negative 3. Had we done that already? Yes, we had tried negative 3.1 and we said that it worked. If you had tried another number like -5, it would have worked as well. So what those values of 3 and, or -3 and 2 do is they tell you the boundary points, and everything less than -3 in this case is true. And we checked between -3 and 2. Did we check any of those numbers? Yes, we tried 0 and 1. They did not work, so everything in this section is false. Did we try anything larger than 2? Yes, and we found out that that worked, so that section is true. If you think about graphing, right? Once we got this x squared, this was our original equation, and once we got one side, well, that's not our original equation. That was our original equation. Once we got one side equal to 0, what kind of graph is this? It's a parabola. So again, if we imagine this number line becoming a graph, is that parabola going up or is it going down? It's going up. So it would look like this, and it would have -3 and 2 as x-intercepts. What are we trying to find with this parabola? We're trying to find with this parabola where it's bigger than 0. In other words, where are the y values bigger than 0? Does it make sense that this is a true section and this is a true section? This review of grade 11 stuff comes into play once we start having parabolas inside square roots. Because in square roots, you can only take the square root of a positive number. If you put a parabola inside of a square root, then you can only have the domain be these sections. So that's something that is going to be where this comes into play in this chapter. So I want you to go down to here now and think about these two functions. We've got our square root function, f of x. We've got our parabola, g of x. And we're going to do a composition of these functions. In other words, one function is going to go inside of the other. In fact, it's going to be the parabola that goes inside the square root. So we're going to find out what values work, what values don't work, and then we're going to try and see what the graph is after we've completed the table. So did you fill out the table? Is this what you got? Now, graphing this, what you have to do is you're putting in these as your x values and these as your y values if you're going to graph this. And you get the following graph. What is the domain and range of this graph? Well, it looks like our domain is that x is between -2 and 2, and our range is x is between 0 and hits a maximum value of 2. At least that's what it appears from the points that we have and connecting those points. We notice that we have some places that are not permissible. So we're going to have to figure out, how would I figure out the domain algebraically if I was solving for this, rather than just plugging in a bunch of points? And how do I graph something like this? Well, that gets a little bit tricky as well. The chances are that you're going to graph this using your skills from chapter 2. So here we just did a table of values. Now I'm going to show you algebraically how you would graph it and algebraically how you'd figure out the domain. So algebraically, what you would do is you would take this and you would write the explicit equation. Well, g of x was equal to x squared minus 1. So you would plug that in for g of x, right? G of x, if I highlight it up here in yellow, there's g of x. So all I've done is replace this yellow part here with what it's equal to, x squared minus 1. Now, what does the function f do? According to the beginning, I'll highlight it in blue. No, maybe I will. Maybe I won't. Yes, I will. Ooh, that's a pretty blue. I like that. what happens in f, it says every time you put something in for x, you do 3 minus that number and then square root it. So if that's the rule, if you put in x squared minus 1, the rule says what you'll do is you'll take the square root of 3 minus whatever you put in. And this time we're putting in an x squared minus 1. If I simplify that in my equation, I get the square root of negative x squared plus 4. We get to use a lot of our units in this unit. We get to use the very first unit we did with transformations. Can you graph negative x squared plus 4? Well, that negative would flip it down and move it up 4. So if I were to graph negative x squared plus 4, I would have a parabola that goes down like that. If I wanted to graph the square root, so this green graph is just negative x squared plus 4. If I wanted to graph in blue, so my blue graph here is going to be the square root of that, then we have to use what we learned in chapter 2. When you're taking the square root of another graph, remember that the points where it's 0 stay the same. The points where it's 1 stay the same. Then look if there are any other nice points you can square root. What's the square root of 4? Square root of 4 is 2. This part will be slightly above, this will be below, slightly above, and this is the graph, which is identical to the graph that we got with our table of values, but I think by doing it algebraically and taking what we've learned from other chapters, we are now more for sure. Yeah, I know that that's the graph. Whereas before I was like connecting the dots and wondering, did I miss something? Maybe it continues. A table of values sometimes doesn't give you that certainty. So that's how we could graph this algebraically. If we were trying to find the domain algebraically, we can't take the square root of negative numbers. We can take the square root of 0, but we can't take the square root of negative numbers. So whenever you have a square root like we have here, we look at the inside, which is the negative x squared plus 4, and we say that inside has to be bigger than or equal to 0. And if that's the case, well, solving this, if I make it equal to 0, I will get x equals plus or minus 2. If I would then make my number line with minus 2 and 2 on there, I know that those 2 points are included because it has an equal sign. And I check something less than negative 2 if I plug in 10, negative 10. Negative 10 squared is 100 times the negative is negative 100 plus 4 is negative 96. That's going to be false. This section, if you try 0, it is true. If you try something like 10, this section's false. So our domain from this says that x has to be between negative 2 and 2. Algebraically, you can't see what the range is. Algebraically, to see the range, the graph is the best place to see the range. And so we can see that it goes from 0 to 2. And we know that 2 is going to be our maximum value because 4 is our maximum value on our parabola before we take the square root. All right, let's look at example 1. Has 2 parts. We've got 2 functions. None of them are square root ones. State the domain and range of each function. Sketch the graph of each composite function. And then state the domain and range of the composite functions. So I'm going to put a green box around this one. Over here I'm going to do domain and range. That's just a line, so its domain and range is everything. I'm going to put a blue box, well, there we go. A blue box around that one. And that's a parabola. The domain of a parabola is everything. For the range, you're going to have to think of the graph and you're going to have to use your transformations. First of all, I might even rewrite this like that, negative x squared plus 4. And we just graphed this in our last example, right? The negative would flip it down. The 4 would move it up 4. So the range of this one is y is less than or equal to 4. And that's exactly the same graph that we graphed inside the square root in the example before. Now we want to sketch the graph of each composite function. It doesn't make sense to graph the green one, graph the blue one, and then try to figure out what the new graph is going to look like. What we're going to do all the time is find the explicit equation. So what does this equal to? Well, g of x is 4 minus x squared. And then f says whatever you put in, add 1 to it. So I'm putting in 4 minus x squared. I'm going to add 1. This is going to give me negative x squared plus 5. What is that? Well, that's a parabola. It's been flipped down and shifted up 5 units. 1, 2, 3, 4, 5. And we've got a graph of our parabola. And once you have the graph, it's going to be easy to say the domain of this one is everything. And the range is less than or equal to 5. For part B, again, we're going to want to find the explicit equation first, f of x. So we start off by saying, I know that f of x is equal to x plus 1. And in my f function, whatever you put in, it says, whatever you put in for x, add 1 to it. So if you put in x plus 1, you're going to put in x plus 1 and add 1 to it, which is just going to give you x plus 2. That is a straight line with a slope of 1. Your domain is everything. And your range is everything. Try number 4 right now.